Morning, everyone. So this will serve as our discussion for lesson 2 in general chemistry. So let's begin on discussing about intermolecular forces. So we've already done discussing kinetic molecular model of liquids and solids. We also done discussing the kinetic molecular theory, and somehow I've already introduced to you some properties of solid and liquid, but uh, but but there is a continuation pertaining to the properties of the solid. So later part on lesson 3 I will be discussing also that. So first, let's discuss first on intermolecular forces. Okay, let's zoom out this one. It said that for forces binding atoms in a molecule are due to chemical bonding. The energy required to break a bond, which is called as the bond energy. So, on somehow way of the process in which two binding molecules, there is such a thing or such process called bond energy. In that bond energy, it is a process in which the forces of each molecule will bind by the means of their atoms, and it explained furthermore on the forces holding molecules together by generally. So if the two forces of a molecules together will bind, it is called as intermolecular forces. Okay, if a forces or two forces holding or binding to each other, the called of that it is called as intermolecular forces process. And it explained also that the energy required to break molecules apart is much smaller than typical bond energy. But intermolecular forces play important roles in determining the properties of a substance. Meaning to say, intermolecular forces is very different to a typical bond energy or a typical bonding of energy of each atom or each molecule. Hence, intermolecular forces is pertaining on the breaking down of molecules. But if we will compare it into the bond energy, it is smaller than typical bond energy. And it actually, in that said, it actually play important roles in determining the properties of a substance. And take a look with the underlying phrases here. It said intermolecular forces are particularly important in terms how molecule interact and form biological organism or even life. So meaning to say, intermolecular forces is not only a typical bond energy, but intermolecular forces will, it's very important in terms of on how molecules interact and form a biological organism. Intermolecular forces is not only on binding or somehow forces that holding molecules, but hence when we say intermolecular forces, it's all about interaction between the forces that holding with each molecules by the means of their atom. Okay, did you get the point? Or it said that when we say intermolecular forces, it is the force that mediates, that is the correct term, mediates interaction between molecules. And not with that also, but intermolecular forces including electromagnetic forces of attraction or repulsion, which act between atoms and other types of neighboring particles. So that is the difference between the band energy and the typical band energy and the intermolecular forces. The typical band energy is like forces binding atom in in a molecule due to a chemical bonding. But if we said it is intermolecular forces, it is the force that mediates interaction between molecules. Meaning to say, it is not only for binding each atom to each atom of a molecule, but it mediates. It focuses on the interaction the between the molecules or between the substance. With that, there is so-called classifying the intermolecular forces, or let's define what are those steps or processes. There are different processes or types to be exact in intermolecular forces. In general, intermolecular forces, it can be divided into several categories, prominent types, or so let's start on defining and explaining strong ionic attraction. So as you can see, in the typical bonding and bonding of energy, it will become process if there is so-called chemical bonding. In in intermolecular forces naman, it has so-called prominent types, meaning to say it has different types on how a molecule will bind an atom to each other by the means of different types of intermolecular forces. And one of the process or one of the type of intermolecular forces is strong ionic attraction. When we say strong ionic attraction, let's recall an lattice energy and its relation to a properties of solid. So the more ionic, it said the more ionic, the higher the lattice energy. What do you mean by lattice energy? So when we say lattice energy, kasi in strong ionic attraction, lattice energy is involved here. So the more ionic, it said, the higher the lattice energy. When we say lattice energy, it is the energy required to break apart an ionic solid and convert its component atoms into gaseous ions. So, meaning to say, it is an energy required to convert one ionic solid, 1 mole of an ionic solid into gaseous ionic constituents. Okay? So, transferring an electron from an element to another element is a strong ionic attraction. Okay? And the strength of the ionic bond is directly dependent upon the quantity of the charges, and inversely dependent on the distance between the charges particles. So always remember that strong ionic attraction also differ in their charges particles between the different substance. A cation, as we all know, cation is a positively charged. A cation with two positively charged will make a stronger ionic bond than a cation with a one positively charged. Yes, of course. Kasi strong ionic attraction, it will differ on how the strongest the particle is. So we need to say if the higher particle is, the higher the stronger ionic bond was. Okay? Always remember that one. And the more ionic, the higher the lattice energy or the breakdown of energy. Okay? So, let me ask you a question. Which ionic bonds are the strongest? What do you think is the ionic bonds which is strongest? So, particularly if we have an example on a periodic table, the combination of magnesium 2 positive and oxygen to a negatively charged or 2 negatively charged has the strongest ionic bond because it explains that it's high lattice energy among all the given options. So meaning to say all the element that particularly in the periodic table has its own charges. Of course, we all know that one. And those element that is very strong pertaining to ionic bond is magnesium positively charged or 2 positively charged and oxygen which is 2 negatively charged. Why? Because it explains that the higher the lattice energy, I yes, the higher the lattice energy and the more which is explained more ang ionic niya. So let's go back to the statement that the more ionic, the higher the lattice energy. So always remember that one. So pertaining to periodic table, there are two important elements that the give the example of strong ionic attraction when a magnesium 2 positively charged combined to oxygen which is 2 negatively charged. Okay? Always remember that one. So that is the first prominent types of electromolecular or intermolecular forces. Okay? Let's move now to the second prominent types of intermolecular forces, which is the intermediate dipole-dipole forces. So I know or I assume that you've already heard the type dipole-dipole forces. Among the prominent types of intermolecular forces, dipole-dipole is very known. Why? There are a lot of elements, to be exact, in a periodic table that we can have the so-called process with regards to intermolecular forces. So, meaning to say, basag na ito. We always use dipole-dipole forces to mix or to bind a certain atom of a molecules. Okay? So, Meaning to say, dipole-dipole forces is a substance whose molecules have dipole moment, have higher melting point or boiling point than those of similar molecular mass, but their molecules have no dipole moment. So it is very different to the strong ionic attraction, kasi strong ionic attraction will depend on the lattice energy of a certain element. So the more its statement, let's go back to the statement of strong ionic attraction, that if it is the more ionic, meaning to say it has a higher lattice energy, while intermediate dipole-dipole forces is depending on the dipole moment. So meaning to say, if those substance whose molecules have a dipole moment, meaning to say it has a higher pertaining to the process which is melting and boiling. But if it is very differ if we explain it to the other element or substance that has no dipole moment. Meaning to say, these are or it is similar to molecular mass, but their molecules have no dipole moment. There is there it undergoes also in the same molecular mass, but the only difference between the two substances is that the other substance has a dipole moment and the other substance has no dipole moment. So that's differ in the intermediate dipole-dipole forces. While if we compare it to strong ionic attraction can be, because it depends upon the charges of the elements, but it will differ on those strongest. That's why it called strong ionic attraction. Kung sinasaad dito or binibigyan ng diferensya ang iba't ibang element kung saan ang mas mataas, kung saan ang mas malakas, on the different charges that they have, for us to identify if that substance has a more ionic, so meaning to say it has a higher lattice energy. But while in the intermediate dipole-dipole forces, it is focused on those element or substances that has a dipole moment. Okay, let's discuss it further to this illustration. So as you can see here in the illustration, we have also charges, the positively and negatively charges. Why? In the dipole-dipole forces or attraction, it's not only on the dipole moment. Meaning to say, if there is a dipole-dipole, or if you use a certain dipole-dipole attraction between the molecules, meaning to say, it is attracted forces between the positive end of one polar molecule and the negative end of another polar molecule. Okay, please be reminded with that. Again, when we say if we use dipole-dipole forces of attraction in a certain molecule or a certain substance, it explains that the attractive forces is between the positive end of one polar molecule and the negative end of another polar molecule. So meaning to say there is a presence of the both positive and negatively charges. So what are those examples of dipole-dipole forces? Of course, it includes hydrogen chloride and hydrogen fluoride. So, and also the water can explain or can give the can be the examples of dipole-dipole forces. Why? Because it explains that the hydrogen atom has partial positive charge and the chlorine atom has partially negative charges. So meaning to say, the both charges is present in each component or in each compound. So one of the example of it is those compound like hydrogen chloride, hydrogen fluoride, and water, which is H2O. Okay? Kasi hydrogen, those compound that has hydrogen and chlorine give a positively charged in the end of one polar and negatively charged in the end of one polar. So what is this so-called one polar, mom? You're always mentioning a polar. So a polar molecule is a molecule in which one end of the molecule is slightly positive, while the other end is slightly negative. So it is called a polar molecule or one polar molecule if the end of a molecule has a slightly positive and the another end of another molecule has a slightly negative. Okay, always remember that one. And polar molecule is present on the attraction, which is so-called dipole-dipole. What are those one example of a polar molecule? Water. Yes, H2O, kasi as I've said a while ago, that the examples for dipole-dipole attraction is H2O, and one polar molecule or a polar molecule has also example, and it is pertaining to H2O. Why? Because the bonds between hydrogen and oxygen are distributed so that the hydrogen atoms are both on one side of the oxygen atom rather than evenly spaced. So meaning to say, this both element has its own slightly positive and slightly negative charges of molecule or a one polar molecule in their both ends. So that is why it is an example of polar molecules. Okay, did you get the point? So if you have a question particularly on the difference between the attraction, you can immediately ask me or direct message me on GC or direct message me on my own account. Okay, so that is dipole-dipole forces. Always remember that dipole-dipole forces is explains on the slightly positive or one polar end of a substance or an element and combine it to another end or negatively end, slightly negatively end of a certain element or a certain substance. So that is dipole-dipole forces. So let's go now on the third what they call this third attraction or prominent type of an intermolecular attraction or forces. So let's discuss now the weak London dispersion forces or the van der Waals forces. So van der Waals forces, these forces always operate in any substance. The force arising from induced dipole and the interaction is weaker than the dipole-dipole interaction. In general, the heavier the molecule, the stronger the van der Waals force of attraction. So, if the dipole-dipole forces is pertaining or focused on the dipole moment or on the two slightly positively charged in the end of the molecule and another slightly negatively charged on the end of another molecules, London dispersion forces or the van der Waals forces is pertaining also on on the statement that if the heavier the molecule, the stronger the van der Waals force of interaction. And this force also arises due to the process of the dipole-dipole forces. So if the interaction is weaker than the dipole-dipole interaction, then this process is called van der Waals forces. To explain it further, so let's begin on this my examples below. So in this example, as we look to the example, we can eventually say that the relative weak electric forces is attracted to neutral molecules to one another in gases. So meaning to say, it is liquefied and solidified gases and in almost all organic liquids and solids pertaining to van der Waals forces. How about with this certain example? We can definitely, it is actually definitely showed the symmetrical distribution and unsymmetrical distribution. The statement that I've been explained a while ago is pertaining to van der Waals forces. It is actually a relatively weak electric forces that attract neutral molecules to one another in gases. So meaning to say, it involves liquefied and solidified gases and in almost all organic liquids and solids. But pertaining to this examples, it involves a symmetrical distribution and unsymmetrical distribution. So if we explain about this kind of distribution, if the atom of a molecule, remember this one, this statement I will be saying to you. If the atom in the molecules are symmetrical in a symmetrical distribution, meaning to say the charges are balanced by each other. But if the molecule or the atom of the molecule is asymmetrical, it is considered to be polar. So meaning to say it is not balanced pertaining to the charges. Meaning to say the both end of the charges has a slightly positive charge and a slightly negative charge in the end. So van der Waals forces has its this kind of process. So it is both involves with the symmetrical distribution and unsymmetrical distribution. When we say symmetrical distribution, meaning to say the atom of the molecules are symmetrical or the charges are balanced. While if we said unsymmetrical distribution or asymmetrical distribution, meaning to say it is considered to be polar. When we say polar, I've already discussed what is polar. When we say polar, these are the substances or the molecule that at the end of the molecule there is a so-called slightly positive and slightly negatively charged, both end. So that explains the asymmetrical or unsymmetrical distribution. So that is the differences between the van der Waals forces to dipole-dipole forces and to the strong ionic forces. So as you can see, van der Waals exceed or let's say exist in the weaker dipole-dipole forces. So meaning to say dipole-dipole forces is involved in this interaction but in the weaker part. That's why it's called weak London dispersion, because of the weaker interaction of the both molecule. So it proceed or it exceed also or exists also in the distribution, namely asymmetrical and unsymmetrical distribution. So that is the weak London dispersion forces or van der Waals forces. Let's go now on the hydrogen bond. Hydrogen bond is very easy to explain why by the means of its name, hydrogen. Meaning to say, it is the bonding of hydrogen. So it is the interaction, sorry with this one. Let me fix it first. Okay, done. So again, when we say hydrogen bond, it's very easy to identify that the process is a hydrogen bond because, meaning to say, this kind of bond is involved of an element which is called as hydrogen. It is interaction involving a hydrogen atom located between a pair of another atom having a high affinity for electrons, such as a bond is weaker than an ionic bond or covalent bond but stronger than van der Waals forces. So meaning to say all of the forces or attraction are connected to each other, but they are differ depending on the charges or depending on how weaker the forces is. So it definitely explains that hydrogen bond is strongest than van der Waals attraction or van der Waals forces. So meaning to say if we use a hydrogen bond, it is more stronger than van der Waals because all of the forces or attraction, the weaker forces or attraction in a certain process of intermolecular forces is the van der Waals attraction. And hydrogen bond is being performed if an element or a certain substance has its element which is called as hydrogen. Okay, that's why it's called hydrogen bond, because it has an involvement of hydrogen atom. Okay, so that is hydrogen bond pertaining to the prominent type of intermolecular forces. So now let's proceed now on discussing the fifth bonding, which is called as covalent bond. So I know on our previous topic in general chemistry 1, I've already mentioned covalent bond. Covalent bond is pertaining also in the chemical bonding. It is a kind of binding also of energy pertaining to chemical bonding. So it is very, I assume that you've already know this one because this process is very easy also. It is actually sharing of charges to each other. Okay, so that is covalent bond. And covalent bond also exists in two part of molecule. We also it also defined on non-polar and polar molecule. So covalent or it in the statement it said that covalent is really intramolecular forces than intermolecular forces, so rather than intermolecular forces. So in our later part of the discussion of this semester, I'm already introducing also the intramolecular forces. What is the definition between the two forces? How does the two forces connect to each other? And what is the importance of knowing the difference between intermolecular and intramolecular forces? Okay, let's proceed again on the bonding, which is covalent bonding. So it mentioned here because some solid are formed due to covalent bonding. Covalent bonding holds atom tighter than ionic attraction. So again, when we say covalent bonding, it is all about sharing of charges. Okay, it's like the negatively charge of electrons, sharing of electrons to be exact, and the positively charged of electrons will mix or bind to each other, and it will produce a certain bond which is called as covalent bond. So if we compare covalent bond to ionic bond, it is much more tighter, to be exact, on the attraction or the forces between the bond, because covalent bond is pertaining on the sharing of electrons, while in ionic attraction it is pertaining on the lattice energy of each element. Okay, so it is again, always remember that covalent bonding holds atoms tighter than ionic attraction. So kasi ionic attraction will depend on the lattice energy of each element than covalent bond. Kasi covalent bond is between the combination of or the mixing or binding of both electrons in a certain element, sharing of element, that is covalent bond. Okay, so let's proceed now on the sixth part of prominent types of intermolecular forces. So metallic bonding. Forces between atom in metallic solid belong to another category. Valence electrons in metals are rampant. They are not restricted to certain atoms or bonds. Rather, they run freely in the entire solid, providing a good conductivity to heat and electric energy. This behavior of electrons gives the special property such as ductility and mechanical strength to metal. So it is very easy to identify what is metallic bonding. Why? Because when we say metallic bonding, it involves metals element. Meaning to say a metal element, those element that is in the metal part. Why? Because all of the element that uses a certain forces like metallic bonding give a special property. Sorry with the pronunciation. Special property, and that special property is called ductility and mechanical strength. Remember that all of the forces in intermolecular forces is differ. Metallic bonding is only the bonding that has a special property such as ductility and mechanical strength. Why? Because those elements that uses a metallic bonding or shares in the metallic bonding are those elements that is in the metals. Okay? So along the discussion, you'll be actually knowing those properties if it is in metal, non-metal, and metalloids. Actually, in our general chemistry one, I've already discussed that one for my previous student. But I think hindi ako ang general chemistry one mo. But I hope and I assume that you've already discussed the properties of metals, non-metals, and metalloids. So what are those elements that give power of conductivity, that produce energy with their own, produce heat? So what are those elements? I know you already know that one kasi we've already done discussing what are the element in periodic table. Today, we will be tackling about the forces or the attraction of different elements. So let's it's like a review na per periodic table. Review all your access about or learnings about periodic table because we will be applying that one in the intermolecular forces, and not only in the intermolecular forces but also in the intramolecular forces. So along the discussion, we will be differentiate the both attraction or the both forces. Okay, so again, on the going back to the discussion, which is metallic bond, all of the bonding is being proceeded or exists in the means of if the element is in the metals part, because this is only the bonding or the interaction which has a special forces or special properties, and that special properties is called ductility and mechanical strength to a metals or a metal element. Okay, so that was the prominent type of intermolecular forces. So if you have questions, clarifications, you can ask me on group chat since it is pre-recorded video. So you can PM me directly in my account if you have questions. Okay? So this is the sixth prominent type of intermolecular forces. I hope you've already identified what are the differences between the bonding and what is the differences between those type of prominent attraction. Okay, so with that, let's proceed to another topic, which is called the properties of liquids. Okay, so intermolecular forces. So not only liquids but also the intermolecular forces. So as you can see, there is one, two, three, four properties of liquids. So on lesson 3, I will be discussing the properties of solid. Okay, so let's give the differentiate between the properties of liquid and the properties of a solid later on. Okay, for properties of liquids, the number one properties is viscosity. Viscosity is a resistance of a liquid to flow. It is very easy to know kasi I've already highlighted the important meaning of a certain properties. Viscosity, a liquid to flow, a resistance of a certain substance to flow. Meaning to say, liquid is the one, or liquid has a power to flow, 'di ba? Kasi solid naman has no power to flow. Magiging power niya lang 'yon with their properties. Magiging involvement niya lang 'yon sa property niya if the liquid will melt. And solid pala. If the solid will melt. And if the solid will melt, it will not a solid anymore. And it will change into liquid. So, viscosity is only a property of a liquid. It is a power of a liquid. Why? Liquid is only, in the state of matter, has the ability to resist or to flow. Ability or resistance to flow. Okay? So, to explain it furthermore, the greater the viscosity, the more slowly the liquid flows, measured by timing how long it takes and a certain amount of liquid to flow through a thin tube under the gravitational forces can also be measured by how long it takes steel spears to fall through the liquid. Viscosity decreases with increasing temperature. So, not only with the statement that viscosity is a resistance of a liquid to flow, but also take a look with the statement that viscosity will only occur if, or viscosity has its level which is decreases if the temperature is increased. Okay, always remember that kind of statement. Viscosity decreases with increasing temperature. So somehow this is the disadvantage and advantages of a certain properties of a certain state of matter. Okay? So I hope you understand now what is viscosity, this resistance of liquid to flow. So only liquid has a power to flow. Okay? If we compare it to the properties of solid, there is no so-called viscosity. Why? Because solid is a hard one. So meaning to say, if the solid has a viscosity, it undergo now with the process which is melting point. Meaning to say, na-melt na si solid, and from the solid itself, it will change into a liquid. So hindi na siya magiging properties of of solid. Nasa liquid na siya kapag nag-undergo na ng process na melting point. Okay? Next to that is surface tension. Okay, surface tension is an energy required to increase the surface area of liquid by a unit amount. So, let's explain it furthermore when we say surface tension. So, meaning to say, if the property or the substance of a certain, or the substance of the surface of a liquid allows it to resist an external force due to cohesive nature of the water molecules. So that is surface tension. Again, when we say surface tension, it is the property or substance of the surface of a liquid that allows it to resist an external force due to the cohesive nature of the water molecules. So, what are those examples of surface tension? Another example of surface tension is a property of a liquid surface displayed by its acting as if it were stretched elastic membrane. So, if take a look if there is, or try to put a water in a certain mug or cup. Put a water, yung pinakadulo ng higher as much as possible volume of a water na pwedeng punuin ang container, then put a certain piece of paper, 'di ba? In the top of the water, or not a piece of paper, no, a pin or a clip in the surface of the water. Put, as you can see, if a pin a pin will not go down, right? Kasi the property is now resist an external force. So meaning to say, mas umiibabaw pa rin ang bigat ng thing na nilagay mo doon sa tubig. Kahit mas marami, kahit pang punuin mo yung baso, pero mas mabigat pa rin yung nilagay mo na pin or clip. Hindi siya lumulubog. Mas magaan, to be exact. Sorry. Okay, let's reverse the explanation. Kapag mas magaan yung thing na nilagay mo sa surface, lumulutang siya, right? Okay, so that explains the surface tension. Clip or a certain pin, mas magaan sa volume ng tubig na nilagay mo, kahit punuin mo pa yan, lumulutaw ang clip and pin because of a resisting to the external force due to cohesive nature of a water molecules. So that explains the property of a liquid, which is called surface tension. Okay? So understand? So if you have question or clarification, just ask me on our GC or direct message me. Okay? Again, surface tension, try to put a water in a mag or in a cup. Then kahit punuin, it's okay. Then afterwards, put it above in the surface of the water. Put a clip or a pin. Hindi siya lumulubog. Okay? Nasa surface lang siya. And that's called surface tension because it produces the thing resists an external force. And that thing or in that forces is due to the cohesive nature of the water molecules. So that is surface tension. Next, we have vapor pressure and boiling point. So it is very easy to identify the property of a liquid pertaining to the vapor pressure and boiling point because it involves the process of the boiling point itself. Liquids boil when its vapor pressure equals the external pressure acting on the surface of the liquid. Temperature of boiling increases with increasing external pressure. Normal boiling point of a liquid at 1 atmospheric pressure, ATM, when we say ATM, it is called as atmospheric pressure. Okay, again, point of a liquid at 1 atmospheric pressure. Higher pressure causes water to boil at higher temperatures. So again, vapor pressure and boiling point considered as the properties of liquids and in the means of intermolecular forces. Why? Because liquid also undergo with the process of boiling. And if the liquid will boil, the vapor pressure will exist. And by that, the external pressure acting on the surface of the liquid temperature will now boiling, and it will lead to the level which is increased. With the increasing external pressure of that, the normal boiling point of a liquid is at its constant number, which is 1 atmospheric pressure. So cause water to boil at a higher temperature. So when we say atmospheric pressure, it describes as the pressure exerted the weight of the atmosphere. Okay, so ATM stands for atmospheric pressure. So that is vapor pressure and boiling point pertaining to the properties of liquids. Lastly, we have molar heat of evaporation. When we say molar heat of evaporation, this is the heat absorbed by 1 mole of a substance as it is converted from a liquid to a gas. So molar heat of vaporization is undergo with a certain calculation or formula. Kasi why? It involves now a certain mole. So meaning to say, it depends on the heat absorbed by 1 mole of a substance and converted it from liquid to a gas. So that's why it's so called vaporization, because as we all know, the process vaporization will lead to an explanation that if the substance is a liquid, then change it into gas, the vaporization process exists. Okay? So that's it. That is the properties of liquids in the intermolecular forces and intermolecular forces itself and its prominent types. So if you have question clarification with regards to discussion in a pre-recorded video, you can message me in GC or you can direct message me on my account. So thank you very much for listening. I hope you understand something and you learned something for this topic, and have a safe day, and always have a nice day also. So thank you very much everyone, and goodbye.